Good morning students, I hope you all are good. Today we are going to learn the lesson number 4, electromagnetic induction and alternating current. We have completed electromagnetic induction, am I correct? Today we are going to discuss AC current. In that AC current we are going to discuss resonance in series RLC circuit. What is the topic? Resonance in series RLC circuit. So before we are going to discuss this resonance in the series RLC circuit, just we recall that what we discussed in our previous class. We discussed in our previous class AC circuit containing inductor, AC circuit containing resistor, AC circuit containing capacitor and RLC circuit in series combination. These questions we have discussed, isn't it? So today we are going to discuss resonance in series RLC circuit. Resonance in series RLC circuit. When the frequency is applied, how to apply means using source of alternating voltage. What is that? The frequency of the applied alternating source. The frequency of the applied alternating source. What is the frequency of the applied alternating source? Means that represented by omega r. What is this called? Frequency of the applied alternating source. That is equal to the frequency of the alternating source is equal to the natural frequency of the, what is here natural frequency? Means natural frequency is defined as 1 by root of LNC. So the alternating source omega r is equal to the natural frequency of the RLC circuit or series RLC circuit. So the frequency of the applied alternating source is equal to the natural frequency. Natural frequency represented by 1 by root of LNC of the series RLC circuit. For this condition, the current reaches the maximum value of the circuit. So current in the circuit means RLC circuit. Okay, current in the circuit reaches its maximum value. What is that? Maximum. One more question. When the reaches the current maximum value means definitely we are applying the alternating source frequency is equal to the what frequency? Natural frequency. That time the current in the circuit, which circuit? RLC circuit, reaches its maximum value. Important one more question, please note it down. Current in the circuit reaches its maximum value. The circuit is said to be two more question, electrical resonance. What is that? Electrical resonance. Define electrical resonance means the frequency of the applied alternating source is equal to the natural frequency of the series RLC circuit. That time the current in the circuit reaches its maximum value. The circuit is said to be electrical resonance. Next, another two more question. The frequency. What is that? The frequency at which the resonance takes place is called resonant frequency. Important 2-mark question. Resonant frequency. What is that? Resonant frequency. Underline that. Underline. See that? So the frequency at which at what frequency the resonance takes place in the circuit is known as or called as resonant frequency. So 1-mark question, 2-mark question, 2-mark question. First 2-mark question, electrical resonance. Second 2-mark question, resonant frequency. What is that? Resonant frequency. So once again, this is very important topic. When the frequency of the applied alternating source is equal to the natural frequency of the series RLC circuit, that time the current in the circuit reaches maximum value is called electrical resonance. The frequency at which the resonance takes place is called, what is that? Resonant frequency. What frequency? Resonant frequency. So the resonant angular frequency, the resonant angular what frequency? Angular frequency. So the resonant angular frequency represented by omega. It is not W. It is omega equal to 1 by root of L into C. What is that? The resonant angular frequency omega R equal to 1 by root of L into C. Or we can represent F for the resonant frequency 1 by 2 by root of L into C. What is that? L into C. At the series resonance, the condition is at series resonance. What is the condition? The condition is at the circuit is series. So that circuit, the resonance, what does that mean? It is nothing but omega R L equal to 1 by omega R into C. We have discussed in our previous class. Here omega L is nothing but we have discussed in our previous class. AC circuit pure inductor, AC circuit containing pure resistance. See that XL equal to omega L, isn't it? XC equal to inductive reactance, inductive capacitance 1 by omega C. Using this relation, I write this equation. Omega R L equal to 1 by omega R into C. Okay. Next, here we can write that XL equal to XC. What is that? XL equal to XC. Here, one more equation. See, omega R L. See here. Omega the R equal to 1 by LC. This equation we can square that R omega square R L is equal to 1 by LC. If you take the square, if you square on this equation, you get this equation. Omega square R L equal to 1 by LC. But omega R L without means root of LC. Got it? So XL equal to XC. That means since XL and XC are frequency dependent, what is that? Frequency dependent. What is that? Frequency dependent resonance. XL equal to XC. This condition is applied. When they apply, it means when the varying frequency of the resonant circuit. When this condition is applicable, XL equal to XC. It is achieved by varying the applied voltage. Varying the applied voltage. XL X equal to XC. The condition applied, when we applied means varying the applied, important one more question, applied voltage. Here what is the applied voltage? You see the frequency of the alternating source. The alternating source producing frequency omega r is there. No, this is that. What is that? Applied voltage. This applied voltage we can vary. What we have to achieve? We can achieve XL equal to XC. What is that? XL equal to XC. That time the circuit attain or obtain the maximum current. The maximum current. This is what is that? Resonance in series RLC circuit. Number of one mark. Very simple way to prove that the resonant angular frequency represented by omega r equal to 1 by root of L and C. In other words, ordinary frequency F1 equal to 1 by 2 by here r represents resonance 2 by root of L and C. At series resonance, definitely the resonance condition we can apply omega r L equal to 1 by omega r into C. Inductive reactance equal to inductive capacitance. So XL equal to XC. When this condition is obtained means definitely we are varying the applied voltage. We are getting the condition XL equal to XC. When means since XL and XC are frequency dependent resonance. Frequency dependent resonance. Sorry for the interruption. Shall we continue? So once again, resonance in series RLC circuit, the frequency applied alternating source is equal to the natural frequency. That time the current in the RLC circuit reaches the maximum value is called the electrical resonance. The frequency takes place at the resonance is known as resonant frequency. When we are getting final equation XL equal to XC. Next we are going to discuss the new topic. What are the effects our next topic, effects of resonance. This is our next topic, effects of resonance. Just to recall the topic name, effects of resonance. Effects of series So effects of series resonance. When the series resonance occur, condition, when the series resonance occur or happen, when the series resonance, say underline no, when the series resonance occur, when that occur means the impedance of the circuit. What is that? The word, see that? The impedance. What is that? Impedance. Circuit become minimum and is equal to resistance of the circuit. What is that? Resistance of the circuit. circuit. So what is our condition? The series resonance can be takes place. When it can be takes place, the impedance of the we are considering circuit become minimum. See that important normal question. What is the question means? The series resonance can be occur the following reason. The reason is the impedance of the circuit becomes minimum and is equal to resistance of the circuit. See that impedance represented by the symbol Z, we have discussed in our previous class, isn't it? Resistance represented by R. So the impedance of the circuit become minimum and is equal to the resistance of the circuit Z equal to R. Definitely what will happen when the series resonance can be takes place? Any doubt? So we how to obtain? We can draw the graph. Graph drawn. Graph is between current frequency and current. So we can draw the graph between frequency and current. I will draw later. So impedance Z, nothing but Z. What is that mathematical expression? R square plus XL minus XC to the whole square. Isn't it? So impedance of the circuit become minimum and is equal to for what? Resistance. R means resistance equal to R. So what happened this time? The current in the circuit is maximum. So what is that? When impedance is minimum and is equal to the resistance of the circuit, the current in the circuit, therefore the current in the circuit is considered to be current represented by impedance, no. So Im equal to by impedance root of R square plus XL minus XC to the whole square. Im equal to Vm by R. R you can write Vm divided by what is that? Ez. Because see here Z equal to root of R square plus XL minus XC to the whole square equal to R. So the current in the circuit we can use this relation. What relation we can use means Im equal to Vm divided by root of R square plus XL minus XC to the whole square R Vm divided by Z. Don't get any confusion how this equation obtained because we already discussed impedance equation, isn't it? So Im equal to Vm by R. Instead of because why I want to written R means because impedance is equal to resistance of the circuit. That time only they are reaching the resonance, series resonance. So our aim is effects of series resonance. What is that? Effects of series resonance. So see here the graph, you can draw the graph between frequency and current. How that the resonance can be obtained. See, first we will draw that X and Y axis. See here in the X axis what we have to take means frequency. Y axis current. Okay. If you draw the graph is obtained like that. See. This is the resonance frequency Fr. Two narrow curves are there. See, two curves. See, first curve, this indicate R small. When this curve indicate R large. Using this curve, we can determine what we can determine means the series resonance. We can determine. Okay. How means? See that whenever the resistance value is large, see here. Resistance become large or high, the curve obtained flat. How that? Flat. See. Whenever the resistance is small, this become small. The curve is narrow. How that? The curve should be important. One more question. When the resistance is high, the series resonance can be obtained narrow, flat. When the resistance becomes small, the curve should be, what curve means? The resonance curve should be narrow. Important one more question. Please note it down. So the maximum current in the resonance limited by the, so which one is to be limited? The maximum current means, see here, I written here. Sorry. So I didn't written. So I write now. The maximum current. The maximum current in the circuit determined or limited by circuit is limited for what factor means it is limited by the resistance of the circuit. Resistance, what is that? Important one more question. So when the resistance is more, definitely the current entering the circuit will be low. When the resistance is low, the current easily flows to the circuit. These things we are the effects of resistance we have discussed in our previous chapter, second chapter, and 10th standard, 9th standard itself we have discussed. Am I correct? So no need to explain more. So the maximum current in the circuit is to be limited by the, what is that? Resistance. So effects of series resonance. Okay, so two more question, one more question, then important problem derived using these formulas. So in our next topic, applications of series RLC circuit. What is that? Important 3 mark question and 2 mark question and 1 mark question also. So applications of series RLC circuit in the resonance series RLC circuit. What is the next topic? Applications of series RLC resonance circuit. Applications of series RLC resonant. So what are the applications takes place when we are using the series RLC circuit? It will be used in the filter circuit. First application, filter circuit. Filter circuit means we will be discussed in our 2nd volume, 9th lesson, very deep. So filter the AC or DC. So filter circuit it will be used. Next, it will be used as a oscillators. Next, voltage multiplier. What is that? Voltage multiplier. So an important use of, these are common use, filter circuit, oscillator and voltage multiplier. An important use of this RLC, uses of RLC, series RLC circuit is to be tuning the radio and TV system. So this is the very important use, tuning the radio and TV systems. When we changing the channels or changing the what is that particular thing. So in radio or TV, when we are using remote, we are changing the next channel. How means that is called tuning. How it is possible? In that remote control, we are using the what we are using means RLC. Resonant circuit is responsible to changing the channel. How it is possible? We see that. Okay. So next, what are the important application of RLC resonant circuit? Means tuning the radio and TV systems. How it is possible? In the tuning circuit, consists of the tuning circuit. What thing is there to change? Varying capacitance, varying capacitance, varying capacitance of, important one more question, parallel plate capacitor is the responsible for, what is that? Tuning circuit. This tuning circuit containing varying capacitance of parallel plate capacitor. This parallel plate capacitor changing that channels, radio and TV systems. Okay, so resonant frequency circuit. Resonant frequency circuit. Definitely, what is the component? The tuning component. The tuning component. The resonant frequency circuit is varying capacitance of the parallel plate capacitor. When the resonant frequency nearly equal to the next resonant, what frequency? Resonant frequency nearly equal for what? Nearly equal to the resonant frequency nearly equal to the applied frequency equal to the signal frequency. What is that? Signal frequency. Signal means we can apply frequency. When it will be possible means the amplitude of the current. What is that? The amplitude of the current is maximum. The amplitude current is maximum, then only the resonant frequency equal to the what frequency? Signal frequency. When it is possible, the amplitude of the current is maximum, that time we are getting frequency or the desired frequency alone received by the station. These are the conditions. Okay. The tuning component consists of, in the series resonant circuit, varying capacitance. This is help for the tuning the radio and TV system. How it is possible? The resonant frequency is equal to the signal frequency. That means when it is possible, the amplitude of the circuit, the amplitude of the current in the circuit is to be maximum. Definitely the desired frequency, desired means we are deciding frequency is to be received alone by the environment station. So if you have applications of RLC resonance circuit, it will be used as a filter circuit, oscillators, voltage multiplier. And important use means tuning the radio and TV system. How it is possible tuning? What are the components in the tuning circuit consist of? That means resonant frequency circuit consists of variable capacitance of parallel plate capacitor is the component to change the or tune the radio and TV system. Got it? So what are the topics we have discussed? The frequency, that means the resonant frequency in series RLC circuit, the effects of RLC, that means series resonance, the resonance when it takes place or the series resonance occur. Next, what we have discussed, applications of series RLC resonant circuits. So next our topic, an important 5 mark and 3 mark question, and also 2 mark, 1 mark important problems, problem based question, compulsory questions. Q factor, quality factor, shortly called as Q factor. What is that? Q factor. What is our next topic? Important topic. Definitely this topic always, any one of the question will ask in the public examination, 1 mark level, 2 mark level, 3 mark level, 5 mark level, okay, and problem, compulsory problem. So quality factor. Or we call this Q factor. What is that? Quality factor or Q factor. The current in the RLC circuit. What is that? Current in the RLC circuit become maximum of resonance condition. The current in the what circuit? RLC circuit become maximum at resonance. See the words, become maximum at resonance. We have discussed what is resonance, isn't it? What happened? We have to increase the current. Increases the current. What will happen? Definitely the voltage across the voltages across L or C. The voltage develop or the voltage increases or develop across L or C. That means the voltage increases inductor or capacitor. Now the definition of Q factor or quality factor. What is that Q factor or quality factor definition? Means see, the ratio of the voltage across L or C. Here L means inductor, C means capacitor, isn't it? Quality factor is defined as the ratio of the voltage across L or C to the applied voltage. What is this? Don't memory. Use this relation when I pass home. So quality factor can be determined by, or quality factor defined as the ratio of the voltage across L or C, inductor or capacitor, to the applied voltage is called what is that? Quality factor. So current in the RLC circuit become maximum at resonance. When we increase further in the current, the voltage develop across or increases across where? LRC. So we can define the definition of or define the quality factor. Quality factor is defined as the voltage across LRC to the applied voltage. What is that? To the applied voltage at resonance. What is that? At resonance. The condition is at resonance. The circuit become purely resistive. Important one more question. When that circuit become purely resistive, at resonance the circuit become purely resistive. That time the applied voltage, what is that? The applied voltage is equal to the applied voltage is equal to the voltage across R. These are the 1 mark points, so please note it down. So the resonance, the circuit become purely resistive. That time the applied voltage is equal to the voltage across R. So quality factor, Q factor can be written. We will write like that. Im into XL divided by Im into R. What is here? Im means maximum current, isn't it? We have discussed. So equal to XL divided by R. Any doubt? The Im cancel, rest of become XL by R. So Q factor. What is that? XL. What is XL? Omega L, isn't it? Because we have discussed in the circuit containing pure inductor XL equal to omega L. So omega L divided by R. Here what is omega means 1 by root of L into C, isn't it? Omega is equal to 1 by root of L into C. So substitute. So numerator L and denominator R is there. Instead of omega, what you have to substitute? Root of L into C. So we have to solve this equation. So here that L, I will write L into root L into L. If you multiply, we are getting the numerator for this equation. R into root of L into root of C, because easy to cancel. So rest of the term. So see, I will write like that, 1 by R root of L by C, isn't it? Quality factor can be determined by these components: resistance of the circuit, inductor and capacitor. So they will ask 2 more questions. You can write the definition of quality factor first, then finally write this equation, because for the statement 1 mark and equation 1 mark. Okay, got it. So quality factor Q is equal to 1 by R root of L into C. In physical meaning of quality factor indicates, what is that? Physical meaning of quality factor indicates the number of times the voltage across LRC is greater than the applied voltage. What is the physical meaning of quality factor? The number of times the voltage across LRC. Suppose the here L, this is resistance, this is inductor, this is capacitance. Alternating source. Resistance, inductor, capacitance. What is the physical meaning of quality factor? The number of times voltage across LRC is equal to the greater than the applied voltage. Greater than the, what is that? Applied voltage. That is the physical meaning. This is very important question. So once again, quality factor or Q factor is defined as the ratio of the voltage across LRC to the applied voltage. At resonance, the circuit becomes purely resistive. The applied voltage is equal to the voltage across R. We can use the mathematical equation and solve that and get the final equation Q is equal to 1 by R root of L into C. The physical meaning of quality factor is determined or given by that the number of times the applied voltage LRC is greater than the applied voltage. Greater than the what is that? Applied voltage. Okay. If you have any doubt, please ask me. So what are the topics we are discussed? We can recall just resonant series RLC circuit, effects of series resonance, applications of series RLC circuit, quality factor. Okay.